We are looking at your assignment task 2. And we are going to look at reverberation. Now, let's forget this. Reverberation. Now, what is reverberation? I'm going to explain it quick and fast. Imagine we got a room. So I'm going to make a room here. Okay, that's our room, yeah. And let's say in this room there is a teacher. And this teacher is the token. And let's say we got one student in the room, and the student here is sitting here listening to the teacher. In fact, I'm going to draw a ceiling to make it even easier to understand. Now, the teacher talks, and we know that this is going to be like a wave reaching the ears of the student here talking. But when the sound reaches the ears of the student, it's not going to stop there. It's going to carry on going, and it's going to bounce in this wall, and it's going to come back here, and it's going to go up there, hit the wall, and come back here. And what's going to happen is this student is going to be hearing the same, but with a small lapse. Let's say this room measures like 10 meters. And we know that sound travels at 330, 340 meters per second. Now, that's quite fast. Not that fast actually, but it's fast. And this is how it travels in air. I'm going to write air here. Now, anyway, it takes a little bit of time to get here, fractions of a second, and then goes back, bounces, and you hear it again, and it goes to the ceiling and bounces, and you hear it again. And if that is happening in a room big enough, that is going to be uncomfortable. And if that's uncomfortable for that person sitting here, it's going to make this person tired. This reverberation in a theater, in a big classroom, in a lecturing theater, is going to cause this reverberation that is uncomfortable, and is going to cause headache, tiredness. You don't want this to happen. So what you could do, for example, and it's happening in many places, is you might have here in the ceiling some sort of absorption boards, or you might have curtains at the back, or you might have any sort of boards in the room, or perhaps carpets. Yeah. Now, when you are doing this, you are now absorbing these waves, and they are not bouncing back, and then you stop the reverberance or the reverberation. Sorry. Now, what we are doing here is I'm going to work out easily the exercise that you have in your books, in your assignment. And what I'm going to do is give you a formula. So this time of reverberation is equal to the area of the wall absorbing the sound. And then let's say we put here a curtain in this wall. Yeah. This is going to have an absorption coefficient. Yes, coefficient. And this absorption coefficient is given to you. So I'm going to show you I got here in my laptop some of these coefficients. Yeah. So we got here, for example, a gypsum board, and then we got different hertz at which that's the wavelength of the sound, and from there the building engineer will be working out that time of reverberance. Now this is expressed as A, so I'm going to write here A, and A is times the volume of the room. Now, in your exercise, this A, this coefficient of absorption, is given to you. And I'm going to say that for this material, for this fabric, we're going to have this coefficient as being 0.16. Very good. Now, we measure this back wall because we want to find for this back wall. And we find out it is 150 meters square. Now, how you measure the area of a wall? But you measure the width times the height. Okay. Now, we need to find the volume as well. Here, we need to find this volume. How you find the volume? Well, if this is 10 meters, and we say this is 150, then our volume is going to be 1500 meters cube. Yeah? Well, let's find the time of reverberation. Yeah? So TR, time of reverberation, equals the area. We said it's 150 square meters. Then we got A, which is the coefficient of absorption, which is 1.16 here. But I showed you before some tables with different coefficients for different wavelengths, and I explained in the video before what is the wavelength, and I gave you a little bit of how things are calculated. But basically, you take this from tables or information from manufacturers or whatever. And then we need to know the volume, and we calculated the volume knowing the area and knowing the length of the room, and it happens to be 1500. Very good. Now we do this calculation. What we got is 1.6. And what 1.6 what? But it's time, and we're working in international units, so it's seconds. By doing this in your exercise, which you will have different values, but it's the same story, you will be able to answer this question successfully, and that will be task 2 of assignment 1 of unit 4. Thank you.